Right, so this is question 5, a walkthrough of Chemistry Higher Tier Paper 2, June 2024. Rest of the questions are in the playlist, so we'll talk about how to answer the questions with the specification references, options on the mark scheme, and what the examiners had to say as well about how students did on each question. So remember, there's a link in the description below if you want to print off a copy of the paper and the relevant pages of the specification. So if you want to do some revision first, then you need to look up in the specification page 79 where they discuss atmospheric pollutants from fuels. Okay, so always a good idea to have a scan through the question to see what it's all going to be about. But for now, we're just concerned with how oxides of nitrogen are produced when burning fuels. That's for 2 marks. Okay, so fuels are things that release their stored energy, usually by burning them, or it could be in a nuclear reaction, for example. Right, so looking at the fuels in the table, there's some hydrogen mentioned, so there's no nitrogen there. And then we have something called natural gas, so you might be asking yourself, is there any nitrogen in that? So it doesn't tell you anywhere in that question what natural gas is. And the only reference in the specification is about how natural gas is formed. So you might not necessarily have even learnt, as I say, what is in natural gas. So that is going to be a bit of an obstacle to some of you when answering this question. Now, there is a small amount of nitrogen that is found in natural gas, but these oxides of nitrogen are not produced by burning nitrogen in the fuel itself. So these oxides of nitrogen are produced when nitrogen from the air and oxygen from the air react together. Now that doesn't usually happen around you because nitrogen is so unreactive. So we need to link it to something that's happening when fuels are burned. So this reaction doesn't usually happen around you because it has a high activation energy. But when we burn in fuels, it's this high temperature that causes the reaction. So there's enough energy to get over that activation energy. So the molecules of oxygen and nitrogen collide successfully to produce oxides of nitrogen. So it's 1 mark for saying high temperature or temperatures, and a 2nd mark for saying nitrogen and oxygen react. But you mustn't imply that those gases that are reacting are coming from anywhere other than the air. So the examiners say this was not well understood. Some students knew that nitrogen and oxygen were reacting together. However, some thought that nitrogen came from the fuel and some that oxygen is a product of combustion. Only a minority mentioned high temperature, and only about 15% scored both marks. Right, so for 2 marks, we need to explain 1 positive impact on the environment of burning hydrogen rather than natural gas as a fuel, and it says to use table 2. So I'm just going to remind you of some other information that was at the start of this question, and it says this question is about burning fuels in central heating boilers. So you haven't specifically learnt about that, but it says in the future gas central heating boilers may burn hydrogen rather than natural gas. So while you haven't been explicitly taught about this, you have been taught about using hydrogen in fuel cells. So it's from that section and the evaluation of using fuel in that context that you're going to transfer your knowledge. So the answer is there's less climate change or global warming, 1 mark, because no carbon dioxide is produced. Right, so the examiners say some students stated that no carbon dioxide is produced when hydrogen burns. However, many simply described what carbon dioxide does to the environment, rather than stating that burning hydrogen instead of methane, found in natural gas, reduces the rate of climate change. So the examiners also say that many students refer to the greenhouse effect. So remember, it's the additional heating effect that we're after that's to do with climate change and not the greenhouse effect. So overall, around 40% of students scored both marks. So for explaining a negative impact on the environment of burning hydrogen rather than natural gas, we again need to refer to the information that's in table 2. So for 2 marks then, we need to say more oxides of nitrogen are produced, and then link it to a reason as to why this is a problem, and say that more acid rain is produced or it causes more respiratory problems. So the next question is about volumes of gases and calculating those. So you need to look at page 43 in the specification. So the key statement in the specification that we're interested in is that equal amounts in moles of gases occupy the same volume under the same conditions of temperature and pressure. Now we don't need to overcomplicate this and use the fact that 1 mole of any gas occupies 24 decimeter cubed at 20 degrees C and atmospheric pressure, because we're not actually told what the conditions are here, but obviously the conditions are going to be the same whether we're looking at the reactants or the products. So instead we're simply going to use the molar ratios that are shown in the balanced equation. So you can see that for every 2 moles of hydrogen, there's 1 mole of oxygen involved in the reaction. So we've got a 2-to-1 ratio. So we are told that there is 3.50 decimeter cubed of hydrogen. So we're going to need half that amount of oxygen. So it's just half of 3.50, which is 1.75 decimeter cubed of oxygen needed. So that is worth 1 mark, but there are 3 marks available. So we've calculated how much oxygen is needed, but we're also told that that only forms 20% of the air. So if we take that last answer and divide by 20, that will tell us what 1% of the air needed is worth. So then we times by 100 to give us 100%, and the answer is 8.75 decimeter cubed. Right, so what did the examiner say? Over 1/3 of students gained all 3 marks. However, some students appeared to believe that the other 80% of the air was hydrogen. Some tried to involve the relative atomic masses even though these were not provided. A few unnecessarily converted the volume of hydrogen to moles and then the moles of oxygen to volume, not realising that the mole ratio is the volume ratio for gases. But this did score full marks if correct. Right, last part of the question is on fractional distillation, so page 63 if you are doing some revision first. So again, it's a very poorly written specification, so although it doesn't say it, you do need to be able to describe what happens during fractional distillation, explain how it works. Right, so you're going to need to explain how kerosene is produced from crude oil using fractional distillation. The question does give you the first stage, so you only need to explain what happens after the vapours have been formed. So for the first mark, you could say there's a temperature gradient in the fractionating column, or you could say it gets cooler going up the column. Second mark is for saying that the kerosene or kerosene vapour condenses. And the third mark for saying that that happens at the level in the column that corresponds to kerosene's boiling point or boiling point range. but you must specifically mention kerosene in your answers rather than just saying vapours. Right, this is what the examiners had to say. So most scored the mark for kerosene or the vapours condensing, and many also described the temperature gradient correctly. Far fewer scored the mark for linking the height in the column to the boiling point and the condensation of kerosene. Most did not mention the height or level in the column, while others seemed to think that a vapour only condenses at a temperature below rather than at its boiling point. A few students thought that kerosene was either a product of cracking or a polymer. Just over 10% scored all the marks. So the general advice I can give you here is that there's more than meets the eye when looking at the specification about fractional distillation. So you do need to be able to describe how the process is carried out and explain what is happening at each stage and have a practice at doing that. Right, that's the end of that question, but the others are in the playlist. So if you subscribe, you'll be notified when the other questions become available, as I haven't produced all of the videos yet. I will also produce some videos for some other exam papers as well.